Alright guys, this video is been a while in the making. You may or may not know that I have a lathe that I bought, which is over here to my left, your right probably. And then I have a mill, which is, I think, appeared in a couple other videos, a CNC mill over here that's also not hooked up yet. The goal is obviously to get those two pieces of equipment running. What I originally intended to do is to power them with one VFD. So I was going to bring the power into a box, use the VFD to just switch between equipment. I've since learned that that's a little more complicated with the CNC mill because the CNC obviously sends commands to the motor, I think. So it's questionable whether or not I'll be able to distribute power from the box to the mill and have it work properly. The lathe is easier in that it just needs to turn the motor. It does have electromechanical switches on the lathe, so I still have to figure the controls out. However, the powering of the lathe is much more straightforward as far as bringing power to an outlet and then running that power right down to the motor. So, excuse me. So this video is basically a little bit of my journey on making a motor control center, an MCC. And so, like I said, the idea was to bring power into. So the motor control center that I have now is here on the wall, and I got the box off of eBay for like 30 bucks or 60, I can't remember what it was. It was very cheap. It came with a bunch of contactors, and it had been set up for a machine. It had a transformer in it and a bunch of wiring, and they had kind of pulled out what they wanted and left what was in it that I bought on Facebook Marketplace. And so my idea was to have a box that basically armed or energized the VFD, and then the control wiring would also come into the box. And I knew that that was going to have to be on a separate run because you don't want, from what I've learned online, you don't want high voltage and low voltage signal together. So caveat is I'm not an electrician. I'm also at the beginning stages of understanding three-phase. I'm also at the beginning stages of motor control centers. I'm also at the beginning stages of cabinet wiring. I mean, all of it. I am not an expert, so if you are watching this video, I really struggled with this, and I like to think of myself as somewhat intelligent. But normally I pick things up pretty quick. Motor control center stuff, just relays and contactors and, you know, things like, I still question whether or not the neutral wire I've got ran through a switch, and I'm not sure that it shouldn't be directly tied into the box and not able to be disconnected. So if you're an expert and you're watching this video, everything I do is probably going to frustrate you. Some other things that I did that I'm sure are not necessary. So in the original box, there was a bunch of yellow wiring to everything. It was all high voltage wiring. I am a visual person, and so I made sure that each of the three phases, or in this case the 220 that comes in with a neutral, was all color coded. I've got everything labeled, and it's just way easier for a beginner to kind of tell what's what. So it's not necessary, but for me it was important. So drawings will be included somehow in the link underneath the video. You're going to need at least a ladder logic diagram, I think is what they're called, or a ladder diagram, ladder drawing. And then the other thing that I found helpful was to actually do a layout drawing of all the components and how they're connected. My ladder logic diagram is also point-to-point correct. It wasn't originally, but after I got to wiring this, it's now correct. So there may be some things that I did in here that are not best practice. If you see things, comment below. I'm always willing to, hear what I didn't do correctly and what I should have done, because, if I do this again, that'll obviously make the next one better. Some of the other things you'll see is there's still holes in the box. I've got to get plugs for them or something. Not super important, but it was a used box, so I had to do some things inside the box that weren't ideal, with the back plate and a bunch of different stuff. Also, this is an old box, so it's actually the back plate are metric hardware. I think all of the contactors are Fuji, and they're very old. They're robust, but they're old. So terminal numbers are different than what they use now, and there's a whole bunch of different stuff. So anyways, I'm rambling on. We'll get in here and take a look. First, we're going to jump to what I used as tools and supplies, so that you guys kind of know what to purchase if you're going to do something similar. All right, so maybe we'll work forward through how I did it. So I placed equipment first. So you're going to need a drill with the correct drill bit and taps. I used just painter's tape and either a Sharpie or a pen to lay out where the holes go. And then once you start installing equipment, you may or may not need a light. You're going to need something thin enough to either reach down into the terminal blocks or your contactor. This blade can't be too wide. I've found flat heads work better for tightening stuff, but in my case, the Fuji contactors were Phillips only, so you'll probably need both of those. You're going to need zip ties for wiring. You're going to need, obviously, wire strippers and crimpers. You're going to want a label maker. And this actually has heat shrink tubing in it. You're going to want that for your numbering your wiring. Like I said, you're going to want a ladder logic or ladder diagram. This is the one I worked off of and marked up. And then this one is actually the one that was used to verify the wiring after I thought I had it correct. I won't go into this. If you want to learn about ladder diagrams, you're going to want to go online and do a fair amount of research on this. I have another drawing that will be included that's the layout of the equipment. You're going to want, so in my case, I got contactors. I color coded mine. You could also just go everything gray, but I actually color coded mine, and you'll see that in a little bit. Low voltage contactors, I'm doing everything in blue. You won't see those in there yet because I haven't done any of the low voltage controls. I did a mixture of stranded wiring, so like automotive type wiring, and solid core. So some of it, my grounds, some of them are just solid core like you'd use for a house. I'm sure that there's something that's not best practice about that, and obviously that's where you would need to be an electrician to size wiring properly. Most of the stuff I used was 14. I did use some 12 and 10. It's all mixed in there together. It's definitely not electrician approved, but I have these clear things. So this is wiring. This is all my MCC control stuff. I've got and-on lights in here. Got and-on lights in here. I've got all my my terminal blocks in here. Jumpers. You're going to need these spade connectors. You may also need ferrule connectors for the terminal blocks. I've got an extra VFD in here, a bunch of stuff from the old system, so kind of rambling a little bit. And then lastly, I've got you're gonna need EMT, and that is gonna be, let me get you guys off of here. So the EMT box is for obviously the conduit, and that's ran over to there, and that box is controlled by the VFD. So that's the stuff that I used. I'm sure I forgot something, but that'll kind of get you started, and then you can fill in where I obviously probably missed some stuff. Okay, so the idea for the box is this. This is a 100 amp disconnect. The only thing it does is isolate the entire box. All the power stops at this switch. They're cheap. They're on Amazon. If I remember, I'll put links in the description. If not, you can source them pretty easily. So this switch, this brings power into the box. These buttons are arming buttons only. So when it's unarmed, this is lit. When it's armed, this is lit. Eventually, this rotary switch here, which I think is 60 amps, I'm hoping to be able to go between the lathe and the mill. Now, I won't be able to do that under load. I'll have to turn the VFD off in order to switch between equipment. I don't even know how to explain it other than you can't shock load a VFD. So you can't have a load trying to pull voltage. The VFD isn't going to like that. The VFD is the thing that wants to push the load to the motor. So that's a really crappy way of explaining it. Again, I'm not an electrician, but you can't switch under load that I know of. You have to power off the VFD for one piece of equipment, switch, power it on for the other piece of equipment. So right now, this rotary switch is not working. It's not hooked up, and it's probably going to be a while before that happens because I have to figure out whether or not I can actually use the VFD in conjunction with the CNC mill. So for right now, that kind of stopped. I really wanted that to be a part of this, but I think there's a way I can control the motor on the CNC, but right now it's outside of my knowledge base. So we'll turn this on real quick from the outside so you can see how it works, and then we'll take a look inside. So I'll go ahead and power it on, and you'll see immediately the red light comes on. All right, let me do that again. So power on, that comes on. When I push this button, you're going to hear the contactor, and I can hear it humming, and the VFD comes on. So then this, I can turn the VFD off. Also, under a loss of power, so I'm going to pretend like the cabinet loses power. When the power comes back on, the VFD is automatically off. So that's how I wanted this to work. These buttons arm the system. They're not for actually running equipment or anything. They literally just bring power up to the VFD. That's how I wanted this to work. So we'll take a look inside and we'll talk about what's inside. So this box originally had a slam latch. Whatever happened when they took it down, or maybe it had a piece of equipment backed into it, the latch and the whole mechanism was screwed up. So I gutted all that out because I wasn't going to be able to fix it. It's probably, I'm guessing this box here is, I don't know, 10 to 20 to 30 years old. I really don't know, but these Fuji contactors, or the ones in the clear thing over here and then the one I'm using, are very old contactors. So they seem to work fine. You know, I may find out that they have been through too many cycles and there's a lot of carbon on the contacts and it doesn't work like I want it to. Who knows? But Anyways, so there was a slam latch. Now there's just thumb screws that were tapped very poorly and they don't line up well and yada yada. So anyways, we'll get in here. So originally I had all of this wired just with the yellow wires that came with the box because I knew I was going to rewire it correctly. So the way it worked for me is I wired it electronically, and I absolutely didn't care about wire being neat at all. I wanted to test the electrical functionality because I was very ignorant of how boxes work and I was learning, and I just didn't want to have to try to also double duty and get wires exactly where they should be and then have to cut them or move them. So I got this whole cabinet wired up. It looked like spaghetti just so I could test the electrical side of it. I wanted to make sure it worked the way that I had it drawn and that my drawing was correct before I tried to also be, super neat, Mr. Neat guy. So what you're seeing now is different than the way it originally was. It was just a mess in here. And in some ways I would encourage you to do that if it's your first time doing a box, because you're gonna, if you try to be neat and do it all at the same time, I feel like you're going to end up cutting wires short or getting the wrong ends. Sometimes I'd put the wrong end and didn't put a ferrule on and put a spade on, and you just end up having to do a bunch of rework, or you don't get your numbers correct, your wiring numbers correct. And so it was just easier for me to check it electrically and then work on the neatness part. So basically power comes in through the switch right here. This side is obviously hot right now. I may be undersized on this red wire. So then the black wire, there's nothing that I really used it for. So this is L1, L2, and neutral. Even though the switch says L1, 2, and 3, it's 4 3-phase. You know, all this stuff's out of China. But I'm bringing 2-phase 4 wire. So 2 hots, a neutral, and a ground. So I've got red and black are my hots, white is my neutral, then I've got my ground going to the back plate, which still needs to be tightened up. And then I had to cut my back plate to make room for this VFD. I would have loved it if the VFD faced out towards you guys, but the cabinet wasn't deep enough, so I had to mount it sideways. So I had to cut my back plate. I still need to put a bolt in over here, and I need to put a bolt in up here. Just haven't got there yet. But let's see, so my ground is grounded here to the back plate, and then it comes down, and these are all tied together with jumpers. Oh, I don't have a jumper in one of them. Huh, I'll have to fix that. Anyways, and then, like I said, I did color coding because it's just easier for me to instantly recognize it. So everything in the cabinet, there's a caveat here, everything in the cabinet that's white is neutral until the VFD. And Romex is cheap. If I wanted to do this correctly, I should have gotten soft wire that had, some color combo that wasn't black, red, and white being the neutral. So the caveat here is that I ran 4 wire out of the VFD to the lathe. I'm going to, obviously I can see it's coming out of the VFD here, but over there it's going to be labeled UVW, I think. Yeah. And then there's RST coming into the lathe and into the VFD, and this particular VFD wanted me to use R and T, which are on the outside, if it was 220 single phase. So there's a lot here, and then there's a ground. So back to what I was saying. Hot in, switch, black wire goes directly to the contactor. I'm using my red wire to power all of my switches. So that's the other thing. If you're doing this, there's a couple of different options. You can do low voltage switching. So you could do, I think it's either 20 or 40 volts DC, and you'd put an inverter in here and you'd run all this door connectors would be low voltage. And I could have done that. I just chose not to. It's just easier for me to stick with high voltage or medium voltage if you're in the motor control industry, I guess. So black wire's just switched with the contactor, red wire actually comes down and goes into these blocks here with a jumper. So I've got 110 on all 4 points here where the terminal blocks are. I've also got my neutral coming down and going into these 2 tan or gray terminal blocks. So there's also a jumper here. I would encourage you to watch other videos. I'm on a GoPro, so I can't zoom in real close, but there's jumpers you can install in these terminal blocks. That's just something for you to look up. But my terminal blocks came with jumpers. They were doubles, meaning they connect 2 terminal blocks together. There's other kinds you can get where you just snap them off for how many you need to tie together. So neutral, hot, 110, ground. These are actually technically not grounded terminal blocks. So I brought my ground from the back plate into one of these green ones, and that's how I grounded it. Normally these are green, yellow terminal blocks. I can't remember why I didn't buy them. It was either an oversight or a choice. I don't remember, but I just grounded one of the posts. So green's ground. Anyways, so this is where it gets a little more complicated, and if you're wanting to know how I wired this, this is where it gets a little technical. So hot comes in here, and then hot comes around and supplies, let's see, T2, T2, T2. Okay, so hot T2 comes in here and then goes out on both sides. T2 goes out to the stop switch, the top side of the stop switch. It comes through as number 3, and when you look at the ladder diagram, I kind of screwed it up, but it still makes sense. So everything that comes out of this contact is number 3. So 3 goes up here to number 4 and powers the top side of the green switch. 3 also comes back and goes, so 3 comes out of here and goes to the green button. And then 3 also comes out of here and goes to the normally closed terminal number 15 and 16, normally closed contact. And it also jumpers over to terminal 13, which is a normally open contact. Okay, now we're going to go back to the green switch. So out of the bottom of the green switch, we've got 4. And 4 jumpers directly over to power the LED when this is energized. And then out of that is a neutral wire. And everything that's neutral is labeled N2, neutral. The number 4 contactor out of the bottom of the green switch to the coil that latches this contactor. So number 4 goes to this terminal back here. That's the latching coil. The latching coil comes out over here as a neutral, and obviously goes to the neutral bar. Also, so from power out of the black power out of the red button, so potential power comes out, goes over here, hits terminal 15, also jumpers to terminal 13. So then what I did is I've got these sticky zip tie components there. Hopefully you can see them. And I just mounted those across the door. This is split loom. The reason I didn't wrap the split loom is because I'm sure I'm not done adding wires for the rotary switch. And it's just going to be easier if I don't wrap the whole thing up in electrical tape and seal it the way I would normally want to. So right now it's still just an open split loom, but you can see that when the door folds up, it just kind of naturally folds this direction. If I had it to do over again, I would have put this one out here a little further. So hopefully you guys can see kind of the makeup here. So power comes in on T2, goes out the bottom, comes into the top of the green switch, and then there's power jumpered over to the LED on the green switch, and then power here goes out to the coil for the contactor, and then that's also jumpered over to this side of the holding contact. 3 also, power from 3 goes out to this side of the holding contact and a normally closed part of the contact. When the contactor is disengaged, there's power to the LED, which goes right here, and then there's neutrals that are tied together and goes out to the neutral block. When the contactor's engaged in, then this holding contact right here also brings power number 4. The circuit's completed for this part right here when the contactor is powered up. Because these are momentary. Oh, both of these buttons are momentary switches. So they're never latched. They're just momentary. And then the only thing that's latched would be, when I say latched, that's quote unquote latched. The only thing that's latched are the LEDs. So this LED has power when this system's engaged. This LED has power when this system's engaged. Is there anything else? So, and then the last part that I may or may not have said one more time, when this is energized, this goes out. This VFD powers that plug-in, and that plug-in is a twist lock. It is a NEMA L1520. It's a 20 amp plug. They look like this. I'm going to get some placards up here to cover this hole. A placard here to tell me what equipment it's controlling, and then some type of plug for this one down here. The other thing I didn't mention is you're going to want low voltage separated from high voltage. So all my 220s up here and 110, and then all of my low voltage control circuitry is going to be down here. So if I didn't show the rest of the box, this is where the low voltage is going to be. And I had to put a door seal on, painted this thing black, all that good stuff. So, all right. So, for me, this was difficult. It was just a steep learning curve to understand the door controls. There's a whole learning curve about industry standards, which I'm sure I didn't do a whole bunch of them. There was confusion about the fact that this particular box was metric, probably was attached to some metric equipment that whoever this had running. Metric, international equipment, whatever you want to call it, right? There was just a lot. The backer plate is steel. I think they're aluminum now. I'm not sure. Maybe they're still steel. I don't know. Just learning all of the terminology, contactors, relays, which do very similar things or the same thing, terminal blocks, grounding, just a lot to take on. I'm not discouraging you at all. I think everyone should do this. If you're watching this video because you want to do it, it's very rewarding when it works correctly. The next video in this series is going to be all the low voltage controls between this and the lathe. There's going to be a bunch of stuff dealing with the electromechanical switches over there on the old lathe, and hopefully that's going to bring us to a point the next video where that lathe works properly. This box is totally wired up minus this rotary switch, and I'm able to actually use the lathe. That would be the next step in this video series, is that lathe works the way it would if it was hooked up to a rotary phase converter, but instead it's hooked up through the VFD, and all of the controls talk to each other from there to here. So that's the next video in this series. I'm gonna get to it as fast as I can, but it'll probably be a little bit because it's just kind of a slow process learning how all this stuff's hooked together. So and then I'm hoping the third video in this particular series having to do with the motor control center and the lathe will be a DRO with also a RPM readout and all that stuff. So I'm going to put a link below to as many of the products as I can. I'm also going to link to 2 videos that helped me out tremendously, and I'm going to one of which I'm going to butcher his last name, but it's Clow42. He did a series on VFD for his lathe, and that was super helpful. The other video that in some ways was more helpful was something called Lathe VFD wiring conversion with like factory controls. The channel is Blades IIB, as in Blades 2B. His video was extremely helpful as far as taking stock factory old school controls that were meant for just hooking directly to 3-phase and making it so they work with a VFD. His video, I watched it multiple times. It was extremely helpful. It actually goes through a bunch of different controls. So like if you step on an emergency foot stop, which mine doesn't have, but it's basically a way to stop the lathe immediately. It causes the VFD to go into free coast mode. The video is invaluable, so I'm definitely going to watch that. Both of those videos will be linked below. Cloud42, his whole series, I think I'll try to link to the playlist. And then, like I said, next time we're going to go through low voltage control. So I hope this helps somebody. I know there was a ton of rambling. I'm so sorry if you could barely stand my incoherent rambling. It's hard to talk through it all when you're not used to saying the words like contactors and relays and terminal blocks. It's just all hard to keep straight in my mind. So anyways, my apologies. I hope this helps somebody. Talk to you guys next time.